lecture on Auckland, how smart you are. So thank you very much, Professor Chong, for joining us. Dear participants, Professor Peter Han-Ju Chong is the Associate Head of School at the School of Engineering, Computer and Mathematical Sciences, Auckland University of Technology, New Zealand. He received his Bachelor of Engineering in Electrical Engineering from the University of Nova Scotia, Canada, MSc and PhD in Electrical and Computer Engineering from University of British Columbia, Canada in 1996 and 2000 respectively. Before joining AUT in 2016, he had various positions in Nanyang Technological University, Singapore. He also served in the Advanced Network Division at Agilent Technology, Canada. He co-founded P2 Wireless Technology in Hong Kong and Zytric Technology in Hong Kong, New Zealand, and US. His current research areas include machine learning technology applied to software-defined vehicular networks. He has published over 200 journals and conference papers, edited one book, 9 book chapters in the relevant areas. So, with this having a vast profile, so we welcome you to this ATAL Faculty Development Program organized by AICT in association with Government of India program for ATAL learning. So thank you very much, sir, for joining. So now over to you for this session.
Okay, thank you, Dr. Singh, for your introduction. So let me share my PowerPoint, hopefully.
Yes.
Okay. Yeah, I just shared the whole window. Okay. Okay, are you able to see my PowerPoint?
Sir, it is not shared yet.
Not share, yeah. Okay, let me see. Maybe I should choose my PowerPoint. Yeah. Oh, okay, not share yet. Okay, I see. That's right. Okay. It's okay?
Yeah.
Okay,
Now,
good. Okay, right? You see my PowerPoint?
yes.
Okay, so I start, yeah. Okay, good afternoon in your side. Actually, it's 9 p.m. here, so it's good evening to myself. So I'm glad to see many of you to join this program. You know, it's a very good participation rate, for this program. So let me introduce myself. I'm Peter Chong. Actually, I'm from Auckland University of Technology, New Zealand. I'm happy, to be invited to give a talk today. So I have roughly to see your program for this 5 day. Actually, it's very full and very intensive. So I'm sure many of you, are quite tiring and also but I believe that you all will be able to learn some good knowledge from this one. So for my talk today, actually, it will be less technical, more general. So hopefully, that will be able to make many of you in different domain, different area to understand a bit about this topic. Okay, let me start. So as you know, the topic is Auckland, how smart you are. For sure, I believe that you know Auckland is one of the major cities in New Zealand, for sure. Then this talk, actually, we're talking about the smart city. Okay, so my talk is divided into these 3 sessions. The first, just very brief introduction of the New Zealand and also AUT. And after that, I will talk about, some of the relevant topic related in the smart city. At the end, I will go through my current research work on the smart mobility, which is one of the major technology for the smart city. So New Zealand, I think that is something that you can imagine in your side. So whenever you think of New Zealand, one thing in your head maybe is milk powder, honey, lamb, and for sure the movie, right? So I believe that these are the things that people why they know us because of this topic, and that is really true. That actually for the lamb here, we do have quite a lot here. So in New Zealand, actually, every 1 people has 6 lamps. So that means the number of lamp here actually is 5 to 6 times more the population here. So that's why, people will imagine that we have lots of lamp here. That's true. Okay, so what about where we are? Actually, I mean, many of you know that we are actually is very far, at the bottom of the map. Basically that's where we are. So we take a flight from Auckland uh to India, at least take about 20 hours. So this is a very long journey. Okay, so this is the basically the map of New Zealand. Actually, New Zealand consists of 3, major island. One of them is the North Island, and actually Auckland is located on the north side of the North Island, and the middle part actually the South Island. We have the very small one at the bottom is a Stewart Island. So these are 3 major islands to make New Zealand. So I think many of you may know, the capital of New Zealand actually is not Auckland. Our capital is Wellington, which is in the middle between these 2 islands. So originally, we have our native people living in this island. Actually, it's Maori people. So this is how they like to dance, from the picture. So the population is very less, about 5.1 million. And Auckland is the largest city, in terms of the population. So the population of Auckland actually is around 1.6 million. So you can see almost 1/3 of the New Zealand people actually are living in Auckland. So what about in terms of the population density? Actually, it's quite sparse. For New Zealand, for every 1 kilometer square has about 1,500 people. So how to compare to this other population? So I like actually sometimes to look at this number, be interesting about the population density. So one of the most very dense one actually is in Singapore. There's about 7,800 people in every 1 square kilometer. So actually India, even though has so many population, is still not too bad, not too high, 20. China is a 59. And New Zealand actually is, for this ranking, we're very high, which is 166. So quite sparse in the country. So what about city? So the most populated, highest population density city actually is Manila, and some city in India also has very Mumbai also has very high population density. So Auckland actually is still not too bad. We still have a quite even though 1/3 of the population in New Zealand is living in Auckland, but our population density actually is still quite reasonable. Okay, so about in New Zealand, we are actually 8 university. One of them, the first one, with the longest history is the one of University of Otago. I'm not sure how many of you have heard about this university, but that one actually has almost back to 1869. Right now, we have 8 university. AUT, Auckland University of Technology, is one of the 8 in New Zealand right now. For sure, we have all the other well-known one like the University of Auckland and the University of Canterbury. I believe that these two, some of you may have heard about this. So just to have a very brief history about AUT. Even though we became a university not long ago, but we do have a very long history. Actually, back to 1895, we start with as a Auckland Technical School. After that, we upgraded to college, and in 1963, we became an Auckland Technical Institute. And in 1989, we become Auckland Institute of Technology. We became the first polytechnic to offer a degree program in New Zealand. And luckily, in the 2000, AIT is upgraded to become a university as Auckland University of Technology. And actually, we are the first polytechnic so far now to become a university in New Zealand. So our main campus actually is located in the heart of Auckland. So AUT is the largest of the 8 actually New Zealand university. It's the youngest one, but in terms of history, actually we have over 100 years of history. So now we become the second largest and fastest growing university. We have 4 campuses in the city, Auckland, north of Auckland and south of Auckland. So overall, we're about around 30,000 students with over 2,000 academic staff. Over the past several years, in terms of the research, AUT has been doing quite well. For the recent 2022 university ranking by Times, actually AUT right now is ranked the first 250 in the world. And because of this ranking, right now AUT become the second highest ranked university in New Zealand right now. And we have one or few other category actually has done very well. For example, in terms of global research impact of citation, AUT is number 1 in New Zealand. So AUT has 5 faculties, but we do not have a medical school. So for my School of Engineering, Computer and Mathematical Sciences is under Faculty of Design and Creative Technologies. Our school has 4 departments: Computer Science Department, EEE, Mathematical and Mechanical. We have about 130 academic staff, altogether about 3,000 undergrad and postgrad students. I'm also from Department of Electrical and Electronic Engineering. In the EEE department, we have about 22 academic staff, and we offer 3 undergrad degree and 1 postgrad and 1 Master of Engineering. In terms of subject ranking, this year we ran top 450 under the QS World subject ranking. So this is our campus. So actually our campus is has a very beautiful sea, and we do have many beaches in Auckland. So quite reasonable good, because actually because of the less people here. And I think one of the icon, the landmark, I'm sure many of you may have know this one. I mean, I'm talking about this Sky Tower at the lower bottom picture. Because the reason why you may know this one, because if you recall, every New Year, the first country to show the firework normally is from New Zealand. Where they come from actually is from the Sky Tower, this one. That's why that one's become famous now, because every day, first day of the year, you may see this building, tower. So we do have many beautiful scenes. Actually, almost the whole New Zealand, Auckland, is made up of volcano. So that's why we do not have many high mountain, but we have many small mountain made up of this volcano. Some of them are still considered to be active, but so far we're still safe. Hopefully nothing happen, in the near future. So anyway, just want to show you some nice photo to attract you. Hopefully in the future, if there are any opportunity, let's say some conference organized in New Zealand, Auckland, some of you will be interested to come here, to attend the conference at the same time to enjoy the environment here. Okay, let me start the second topic, the smart city. So sometimes I may not like to say, to say this, the topic is the smart city, because I want to say smarter city. That means we are smart already, but we just want to be smarter. Okay, so when you talk about smart city, what's wrong with our city? I mean, if our city are doing quite fine right now, why do we need to put so much effort, every one of us, try to build and deploy a smart city? One of the very important major reason is the population explosion. Because of the huge population right now, that's why there's something wrong with the city that we need to address, we need to improve. So what do I mean? Right now, we're about 7.1 billion population. By 2025, we should have around 8 billion, and by 2050, we have over 9 billion population. So that is a world population. But the problem actually is not this huge amount of population in the world, and actually is the population in the urban city. Right now, urban resident, we have a new urban residents almost 60 million per year. So many people are moving to the city right now. Right now, we have about 3.6 billion, about half of the world population living in the city. But by 2050, we expect that we have about 6.3 billion of the population will be living in the city. That means 2/3 of the population. So in that case, lots of problem will be expected. So due to this population explosion, what are the issue? What the problem right now we need to address? One of them is due to this resources scarcity. What are the resources we're talking about with very limited and high demand? These are the natural resources like the water, energy, food, and land. So as you know, we have limited water, and basically every year we lost almost 32 billion cubic meter of water. And by 2025, again, it's expected that half of the world population will be living in the water deficit area with no enough or clean water. On the other hand, the demand for the energy is huge for all these industry or for those new technology to be driven. So the demand will rise by more than 56% by 2040, and we are trying not to use too much of this petroleum with oil to generate energy. So that's why we need to look for some new solution using some renewable energy. Food shortage is also a major problem due to the climate change, pollution, and all these problem. I mean, the crops fell actually very seriously. Nowadays, 1 billion of the people are affected by hunger. Actually, among them, 33 countries are considered to be really extremely alarming level of hunger. Another problem is transportation. So because of that kind of traffic accident, I believe we all have experienced this, not new to us. So transportation definitely is a very major issue in this smart city with huge population. So again, these are some of the photo I would like to show you the traffic jam, right? The one in Auckland, actually that is considered to be a jam in the most busiest bridge, harbor bridge in Auckland. And some other traffic jam photo, let's say in China, in India. I think in China, India, these are definitely not really exceptional new to us. You know, it happen from time to time. So that's why someone make a joke that, you know, in Auckland, they say, welcome to Auckland, now enjoy your delay. But honestly, to me, actually, before I came to Auckland, I worked in Singapore and also originally from Hong Kong. So the traffic congestion in here, Auckland, to be frank, is really nothing as compared to where I worked before or where, you know, you can experience right now in China, India. But the people here, you know, cannot take it for this traffic. Okay, other problem, aging. I think we have been talking about aging problem for the past more than 10 years. So, I mean, the aging population will be increased to 2 billion by 2050. That means at that time, almost 20 to 25% of population aging. So for sure, a lot of health issue, a lot of medical advance will be required to address the issue. Another is the crime, right? Because of many people, for sure, that's the crime will be increased. So that is also very serious matter right now. Even Auckland, we also can see the crime to be increased substantially as compared to the past. So these are some of the issues with our city due to this population explosion. That's why we need to find some way to adjust them to improve those situations. So believe it or not, smart city, to be frank, is really one of the solution that can help to to solve this problem. Okay, so now I've been talking about smart city, right? What is actually smart city? How to define that a city is smart? Is it that? Is it that we just use all kind of this smart technology in the city, make our city smart? Or you can see many of this technology, basically what did they do? They just put a smart in front. Would that become smart? For sure, we should have some very loose or at least rough definition to define a smart city, not just simply using all these things. So before I talk about the smart city kind of the definition, maybe I go through some of the smart technology with you. All this actually, you may have been experienced or even have this already. One is the smart home technologies, right? For example, we deploy the sensor in the home to prevent some kind of a crime for the security, or some home may deploy this a smart meter or smart energy management system. So that smart energy management system will be able to help you to utilize the energy more efficiently, depending on the period, depending on the load and the time. In some smart technology example, I know, for example, in Singapore, they develop some technologies that they know before you go back your home, the aircon will be switched on maybe 5-10 minutes before you enter your home, so that then you have a very cool environment when you reach your home. So this something like this. Another very popular smart technology is called the smart health, right? So we have been developed many of these smart health application or the technologies, particularly for the elderly people. So for example, one is the, let's say, smart sensor, let's say, to be carried by the elderly people. So those smart sensor will be able to monitor or detect some kind of a measurement, heartbeat rate or temperature, so that all this data will be collected and then transfer, sent back to the family doctor. So the family doctor with good analysis or data about the health, kind of to monitor the health. In case some kind of a health issue, those data will be interpreted and then sent to the maybe sent to the hospital, and then the emergency vehicle will be able to, ambulance will be able to come to rescue the elderly people. So something like this. And then smart street, basically some of them just deploy the sensor to switch on, switch off the light, or they may have the motion sensor to switch on the light when any vehicle or the people moving across the street. And also in some example, they may deploy what they call the smart garbage bin. So basically, the smart garbage bin has the sensor to detect the level of the rubbish, the garbage, so that when the garbage bin is full, so that people will go there to collect the garbage. Another is a smart parking. Smart parking will be rely on many technology, RFID, sensor, communication, or the camera. So basically, as you know, nowadays we may need to manually, to using some coin or whatever to pay for the parking, or maybe we can also need to use some app, to arrange the payment. But now for this one is completely hand-free. So that basically you can park your car on the spot, and then when you leave, and then the system will be able to record, the time, the duration in the parking period, and then also to send you the bill to be paid. So again, that should be quite convenient if you have this smart parking. That means the human will not need to be intervened with this operation. Okay, so the last one, the smart technology is something that actually I don't know whether is useful or not, but that is available. That is the smart toilet. I mean, surprisingly, don't laugh at this technology. Actually, it's very expensive. I just searched Google. They cost almost over 10,000 US dollar, comparable to buy a brand new car. So I do not look at this in detail. I don't know how smart they are. Maybe, but another thing that, this smart toilet will be connected to your smartphone. So that, somehow your smartphone will be communicate with the smart toilet. Maybe what I guess is that maybe before you go to the toilet, the smart toilet will flush the toilet for you to make sure it is clean. Anyway, that's why lots of smart technology, some of them you may not have, even imagined. So, I mean, sometimes we are very creative. Okay, so now we really want to see what is the smart city. Okay, so I mean, I've searched Google, to look at many definition, kind of the description of a smart city. More or less, I try to summarize them, to be expressed in this way. First, the smart city has to be a modern urban city with one important condition is with high population density. What do I mean high population density? That means has not only just large population, but with very limited land. So if an urban city with no high population density, basically, many of that smart technology you may not need because you don't have a problem. So many of this smart city technology is to aim for this objective, is to improve our life quality, create sustainable city, and must be able to drive economy. Otherwise, no one will be interested to deploy to invest those smart technology. How to do that? By connecting many of things, people, resources, information, and the city element. So under the smart city, what are the major technologies right now? I mean, they are using to develop this one will be this five: ICT, information and communication technology; IoT, Internet of Things; AI, artificial intelligence; sensing and big data. So if you look around all these uh, uh, I think most of these smart city technology for the smart city actually are somewhat using some of these five technologies. So these are the six important components to be together, in order to, there are many different smart components, but these are the major one in order to make the smart city to be claimed really smart. First, we have the smart people, smart utility. You know that I refer to, let's say, the smart meter, for them to collect the power consumption. Smart mobility for the future transportation. Smart economic, for example, the e-payment. Smart environment, basically the sensor, maybe examples, the sensor to monitor the environment to ensure, for example, the prediction of the earthquake or the flooding or some of the problem of the environment. And smart living, that can be referring to your smart home, smart building to make our life quality to be improved. So, to me, I will think that will be the general smart city technology framework that we need in order to, let's say, to deploy, to implement this smart city. First of all, a smart city must have deployed a lot of sensor, all kind of sensor that can be used, to measure different type of information, to collect different information, temperature, pollution, or congestion, or whatever, or traffic information. So the sensor are used to collect all this data in different domain, right? But once with this one, then we need the wireless communication to exchange and transfer this information. Because once the sensor collect this information, you need to use the wireless technology, no matter Zigbee, Bluetooth, Wi-Fi, cellular, satellite, to using them, to transfer, exchange the information to each other. So all this wireless technology will be collecting this data and then will be passing through to a central. So how to do that? Again, in that case, we need to rely on the networking technology. For example, internet, IPv4, IPv6, or any other advanced networking technology to pass this data to the center or to the central. So when you come to the central, what are they? Will be the cloud storage. So the cloud storage, is a huge data storage to collect all this data. So after that, once all this data available in the cloud, then you have the big data analytic to nicely categorize them, to analyze them in order to interpret the information. So at the end, once you're able to interpret the data and to understand, to analyze the data, at the end, you need to make the decision. Now, not the human to make because of the huge complexity and variation of the data. So we need to rely on the AI technology. So that at the end, the AI technology will be interpreted to make, based on the big data analysis to determine some decision or some action to feedback to the city to act in the next phase. So that's why I think that will be the a general framework for the smart city deployment. Okay, so now where are they? Do we have the smart city? I mean, from what I recall, actually the smart city, this term, I have heard this over more than 10 years already, maybe in the early 2000s. So for sure, we do have many smart cities around the world. Nowadays, those smart cities mainly aim to reduce the traffic, save energy, and increase the public safety. So by 2025, it's expected we will have about 88 smart cities around the world. Some of the large smart cities actually can really save a lot of money. Some of them can predict to save almost 800 billion by using just the smart mobility technology, not all of them. But that's a huge investment. So by 2025, the whole world is expected to invest 10 trillion of investment in the infrastructure to support this smart city. So these are the example of the smart city everywhere in every country, like South Korea, Sweden, Canada, Japan, US, China, India also has number of these smart city kind of this program and project, and Singapore as well. So let me just show, just briefly to go through a few of the smart city example. One of them actually is Amsterdam. Amsterdam has started this smart city initiative long time ago, since 2009. A number of project has been completed and ongoing. One of their technology or application is called Mobile Park. So basically, I believe that one is a mobile application. The idea is that this one is to provide the parking space in the city of some private household, to rent to their parking to the people who come to work to the city, because I think that's a very good idea, to share the space, because in the city some of the houses, the owner may be working not in the city, so they may leave their house in the morning, so that the parking space will be empty, so that those parking space will be able to rent to those people coming in to the city to work. So that is a really good sharing example. And they also deploy all the smart energy meter to collect the power measurement, consumption without human intervention. They also deploy the smart lighting to control the brightness on the street, with the sensor, depending on the the daylight. They also have this smart traffic management to monitor the traffic in real time. So what they do is to in real time they broadcast the traffic road condition to the driver or passenger, so that they are able to make use of the road for traffic more effectively. Another example is some example in the US. One of them, San Francisco, they have a project called Smart Corridor. I believe that they is on the very long highway. As you know, the US. So they have deployed over 100 this camera sensor. The purpose is to improve the traffic flow. In Seattle, they have I believe that they have developed this smart building technology to aim for the high performance building to reduce the energy consumption. So, for example, by understanding the data, the temperature in the building, they're able to adjust the aircon or heater in order to make the consumption to be more efficient. Another example is the Santa Cruz. So this one, actually, they use the past crime data by the police. So the police make use of this crime data in the past, try to predict the future crime in some high crime area. So one example may be, let's say, in the Christmas day. So they based on the past crime data of the Christmas day in many years in the past. So they're able to predict, in the Christmas day, what time, what period, what region will have higher crime, so that they can maybe, station more police there, to minimize or to reduce the crime happening. So China actually has the highest number of the smart city pilot project. Half of them actually is coming from China. So for the China, they aim to develop 100 smart city by 2020. So I'm not sure how far they can go, because for these few years of the pandemic, I don't think they have able to move so fast. So the smart city in China, they mainly to rely on the AI to control the smart city. One big project in China is called City Brain in Hangzhou, is with Alibaba and Foxconn. So what this Spring project is that the AI will using AI to run the city. How to do that? By interpreting and making real decision. So that means the Hangzhou city will deploy all kind of sensor that will be able to provide to the AI. So, and then the AI will try to analyze them, and then based on this one to make a decision. For example, the traffic decision, once they have this information, they're able to control the traffic light in certain region in order to make the traffic to be more effective or less congestion. However, all these technologies sometimes to bring to us will give us some convenience or give us some advantage, but on the other hand, that also may have some negative effect. So because of the the city brain, as you know, the whole every sensor will be deployed in the city. So in that case, if that city brain project really succeeded, really implemented successfully, then that means everything will be tracked in terms of their social activity, purchase, movement, and commute. So now, whether we want this or not is another social problem. Okay, India also actually is very aggressive. I believe that you know much better than me about this smart city initiative by the government So in 2015, India aimed to set up 100 smart city for the next 7 years, and they have allocated 14 billion budget to invest this smart city. So they aim to cover the smart building, clean energy, transport, water, safety, and smart grid. So by 2032, this is estimated the Indian city will need to accommodate at least 300 billion more people as compared to now. So what do they deploy? For example, I believe that in some state or some city, now are mandatory to install to use the LED light and to install the solar panel in order to save the energy. And also they also deploy many camera, to aim for the preventing the crime. So similarly, they also have one smart parking application. Is a pre-booking parking. So I don't know, you may have used this before. I have not seen this before. So basically, this is a mobile app to allow you to book a parking in advance in the multi-level parking space. So I think that's a very good kind of the technology, so that if you can do the pre-booking, you can ensure that you have a parking space before you go, and also you save a lot of time and energy and this petrol to just drive around the parking, to look for parking, and also you can reduce the traffic jam as well. So what about New Zealand? New Zealand actually has started this as well, but not too aggressive, not too very, a lot. So in 2016, several of these city, Auckland, Wellington, Christchurch, has completed 13 smart proof of concept project. So at the end, from the report, the conclusion is that overall, the project have delivered efficient and effective smart sensing system, able to capture and processing data to produce some useful analytic and for the decision maker. So that is positive in the sense that those organization realize the benefit of the smart city to help to make the decision, but they say that the sustainability of the program is somewhat unclear. What do I mean sustainability? Basically, they're referring to the return of the investment, because they don't see the need now to have this technology, because first of all, the business people will not be able to interest to invest, and they don't see they can really make money, make revenue from this one. So why is that? As I mentioned to you, if you need a smart technology, you have to be a smart city. And the condition to be a smart city is a urban city with high population density. But as you know, in Auckland, actually is not too congested. Even for the traffic jam is nothing compared to many other cities. So even though we have deployed so many of this smart technology here, you may not need them, because anyhow, it's not so serious. So that is the reason why New Zealand or the major city Auckland actually are not too advanced in terms of that smart city technology. However, they also think, conclude, the program is good for sure, because they have invested so much money already. They have to say it's a good program, and the program will be useful. Some of these findings, some of these results will be useful for the government or the private enterprise, okay, in the future. So what other key smart city driver in New Zealand must be government, Ministry of Business, Ministry of Health, Transport, and Auckland Transport as well. So for the Auckland Council, also is interest, to show the interest in this domain. So they have drafted a master plan in 2017. So after that, they really have developed some smart technology example. One of them is called Safe Swim Program. They deploy a number of sensors to monitor the water quality at number of beaches in Auckland. So that, if we have downloaded the app, we'll be informed in advance in case some of the water of the beach are not good enough for us to swim. They also have deployed this storm water monitoring system with sensor with many high-risk flooding area to predict the flooding. Another project is working with the industry Hitachi, is the refrigerator monitoring system. So for this one, basically they deployed maybe the temperature sensor in those truck to, let's say, to transport the food, and also the sensor in those fridge in the supermarket to monitor the quality of the food. Auckland Transport also has interest, so they also have this smart city strategy report, but until now, there not really a lot of project has been carried on. But today, at least to them, they are aware of this one. They will in someday they will go for this kind of deployment for the ITS. Another example is a water care organization. So they almost have deployed all the this smart water meter in all the houses already in Auckland, so that this smart water meter will be able to collect the reading without them to come here to do the manual recording. That will actually save a lot of manpower, a lot of traffic, a lot of to reduce a lot of air pollution. Okay, so now at the end, these are the three key smart factor to make the smart city really able to move forward. First is the smart people. I mean, the smart people, I'm not referring to us, the smart people, us to develop the smart technology. It's the people who are using the smart technology, because still some certain percentage of the people, they may not prefer, to adopt to the new technology. They want to stay what they are. Okay, and then some reason maybe the smart technology will be maybe threaten them in terms of their job security. Second is the smart industry. That means the industry it really have a vision to foresee that that technology will help them to increase their business, to increase their revenue at the end for their business expansion, so that they need to invest. All this smart investment, you will not see the return in a short time. But the most important is the government has to be smart. That means because many of that investment will not have any return, so that the businessman, the industry will not be willing to try. So the government need to start first to put the money to invest, to show the benefit, to show the potential for their business. So I believe the government in India is smart because you have been investing a lot in this area. Okay, so again, we all must have determination to deploy, to roll out this smart city, because we do have the problem in the future if we do not do any action, and three of the party need to work together. Okay, so that's the second part. So let me go to the last part of my talk. So this is basically some of the research I have been doing for the last 5 to 7 years on the smart mobility research. So the topic actually is a V2X technology for future intelligent transport system, ITS. So first, V2X. What is V2X? V2X actually stands for vehicle to anything. V2X actually is a smart mobility technology for vehicular communication networks. V2X is mainly based on wireless and mobile communication and networking technology to make it happen. So the aim of the goal of the V2X actually is to enable vehicles to communicate to other vehicles or access points along the road. So in brief, we like to get vehicles to talk. So what I mean to get the vehicle to talk, that means in the near future, your vehicle will be able to communicate with the other vehicle. What do I mean communicate? That means you're able to exchange the data and information among each other to achieve certain benefit to the driver, to the traffic, or to the pedestrian. Okay, so that is the background why we like to, this is a very important research topic in the V2X, in smart city. So let me show you one video. So you can see, that happened normal, right? I mean, even in Auckland, New Zealand, some animal maybe travel crossing the road, like you can see the lamp on the video. So for the lamb, they're very smart, right? They have no problem. But the problem is the driver. So whenever you have this accident, normally the driver, a passenger will leave the car, to negotiate or to argue. And that is very dangerous. You can see. Again, this is not something made up. Actually, that is the really real car accident in China in 2017. I mean, that's very sad. I mean, if we are able to deploy this vehicle-to-X technology, for sure, this kind of accident, I'm sure, can be avoided. So the traffic accident right now increases dramatically, right, over the past many years. So have many loss of the human life and the property. And many of them, is due to distracting driving, improper driver, and some hustle on the road. And nowadays, the traffic even become more complicated situation, like the intersection. So the driver even more hard now to avoid this danger, like the vehicle and pedestrian passing around in the blind spot. So now to tell why we need V2X research, one of the aim is to use for traffic management and control to reduce traffic congestion and optimize traffic flow. But that may not be the key. The key actually is to have the safe drive, to reduce and avoid car accident, to save life and money. So why safe drive? For sure, because every life matters. So actually, according to the global traffic accident in 2014, 1.3 million people die per year due to road accident. That means over 3,000 die every day, and over 20 million injury. In fact, for this ratio, traffic accident ratio, as compared to aviation, is very huge. That means for the aviation, this kind of ratio refer to every day, one of the small airliner will be falling out of the sky. So if you have this kind of accident for the aviation or for the airline, I think that we will be very, very scared. But you can see, in fact, traffic accident is also quite serious as well. So road crash cost over $500 billion globally. Is it serious? Yes, and also unacceptable. Right now, the road crash ranked number 9, leading cause of death for all death globally. But if you do nothing, you will become number 5 leading cause of death by 2030. That means that is even higher than the cancer or any other major disease causing the death. Can we help to improve? Yes, for sure. That's why we like to work on this topic. And some good example is that right now we have been using one safe technology for car, which is the ESC, electric stability control. We have been using this for quite some time, and the results show that just a simple ESC technology already can reduce 15% car accident and can save 20% of the life. So we are hoping that if we can have deployed this advanced V2X technology, we can even do much better to this result. So what is V2X? So I'd like to show you graphically. So V2X consists of three different components in terms of the communication type. One of them is called V2V. V2V, as you know, stands for vehicle-to-vehicle communication. So for the V2V, we need each of the car need to install one V2X communication box. So you can just say this is just the Wi-Fi, but now using the car. So the V2V means car to car can exchange the data information if they both are within the communication range. But in some scenario, what happens if two cars are far from each other? For example, if the blue car want to communicate with the school bus, if they're too far away, V2V will not be able to let you do that because they're too far from each other. So in that case, we need to use another type of communication. It's called V2I. I stand for infrastructure. So vehicle to infrastructure communication. So for that infrastructure, basically, we deploy the roadside unit to some lampposts, to some infrastructure, for example, traffic light or some lampposts. So those device installed to the traffic light, you can just think of this like the Wi-Fi router in your home or the Wi-Fi router in the ceiling. So under this one, in order for two cars to communicate, then the car need to first communicate with the infrastructure, and then the infrastructure with that router will forward this message to another car. So using the V2I, so the two cars, if they really far from each other, will still be able to communicate through that router or the V2X router installed in the infrastructure. Another type of communication is to allow the vehicle to communicate with the people. P. So this one P stands for pedestrian. So that is vehicle to pedestrian communication. So that means the data from the car and the data from the smartphone of the human being from the pedestrian will be able to exchange. So again, this is very useful application. Imagine if a kid is about to cross the road, if the kid is able to send his information to the cars on the road, then the car may be able to inform in advance that a kid is going to cross. So the car is based on that information, the car can slow down or even stop. So a lot of this accident can be really reduced. So because of these three types, V2V, V2I, V2P, so now we like to call this kind of V2X network as a VIP network. Vehicle to infrastructure to pedestrian. So I will foresee this will be available very soon. In fact, some of the high-end car in the US manufacturing, they already put this V2X module inside the car to let the car to communicate with other car. So I will see, actually that has been going on right now. So maybe 3 or 5 years later, we will be able to see this. Many of them will have this V2X capability. So what are the major technology now standard used in the V2X? Basically 2 types. One is called DSRC, dedicated short range communication. That DSRC has been studied around for over more than 10 years already. So this DSRC is to support V2V and V2I communication by broadcasting the real-time safety message in order to reduce the traffic or to avoid the accident, and using the ITS spectrum at 5.9 gigahertz. So DSRC actually is mainly based on IEEE standard. It's using IEEE 802.11p and IEEE 1609.x. So if you have not know about 11p, but this 11p 802.11, I'm sure is not unfamiliar to you, because that is the 802.11 is the Wi-Fi standard. I think if you have not heard 11p, you must have know 11AC, 11N, which is our current Wi-Fi technology. That is correct. Actually, 11p is also a family of the Wi-Fi, but this Wi-Fi, you can, for simplicity, is a car Wi-Fi. It's a Wi-Fi to be used for the car. Another standard is the cellular V2X. So again, this cellular V2X will support all kind V2V, V2I, and V2P, and also the spectrum at 5.9 gigahertz. And the benefit of the cellular V2X is that this one will take advantage of the widespread cellular network, which is already deployed everywhere. So that one will be able to roll out to be adopted much more easily. Just like for the DSLC, you still need to purposely install this Wi-Fi car router along the road, so that may not be able to be popular easily. So the major cellular technology to use for the V2X is based on 4G, but right now most of them focus on the 5G cellular V2X. Okay, so DSLC, as I mentioned, is one of the really practical technology and product for vehicular ad hoc network. So that will be able to support V2V and V2I. So in the DSLC, basically, each vehicle will generate a safety message. And we call this a basic BSM, basic safety message. We generate and broadcast this BSM from time to time to everywhere, so that other vehicle will be able to receive this BSM message in order to adjust their driving or to avoid some accident. So the information in the BSM, for example, is some of the information of vehicle, the status vehicle, like your location, moving speed, direction, and the acceleration. So all these are the key information for the safety purposes. So that is a very brief overview of the DSLC protocol stack. This one mainly has the 4 layer. As usual, like the Wi-Fi, we have the physical layer, MAC layer, middle layer, and application layer. So the physical layer of this 11P actually is using this OFDM, and the MAC layer is similar to the Wi-Fi 11N and 11AC, also based on collision avoidance, CSMA-CA, to let the vehicle to access the channel to send the message. So above this one is the middle layer, like the 1609.4. That layer mainly actually is responsible for the channel switching and the networking. And above this one, also some of the layer 3 and layer 4, TCP, UDP, and the IPv6. Above this one is the application layer. For example, one application is a VSM. So that is the overview, some of the overview of the channel. In DSLC, each channel is 10 megahertz. And in total, there's seven channels. They are service channel and control channel. Only one of them is a control channel. And according to the 1609.4 channel switching, so basically, one kind of the period will be 100 milliseconds. And this 100 milliseconds will be switched between control channel and the service channel. And the BSM message or the safety message can be sent only under this control channel within this 15 milliseconds. Okay, another is CV2X. So in 2017, 3GPP release 14 has proposed 27 use case under this cellular V2X to minimize the traffic accident and improve the road utilization, and also provide the infotainment in the ITS. So infotainment means that the future vehicle using the V2X, you are able to enjoy watching the TV, movie, or listen to music. So that provide entertainment inside the car through that cellular V2X. And the release 16 has further specified 4 dedicated V2X services. They are including the sensor, vehicle platooning, advanced driving, and remote driving. So the advanced driving and remote driving basically is to aim for the future autonomous driving using the V2X. So mainly V2X actually will be using in 5G and will be adopting the single carrier FDMA, and the channel bandwidth can be 20 megahertz or 10 megahertz, and the band will be using the 5.9 gigahertz band. So that is is a typical OFDM OFDMA channel. So as you can see with the X and Y, the X-axis actually is the time, the Y is the frequency. In OFDM 5G or 4G, the frame duration normally around maybe 10 or 20 milliseconds, but inside this frame is subdivided into a number of subframe. Each one of them is 1 millisecond. And then you can see the square block, right? Each of that square block we call under OFDM is considered as a resource block. One of these block actually it will have 180 kilohertz in frequency and 1 millisecond in time. So that means each vehicle will be allocate one or more of this resource block in order for them to send their information. Let's say safety information or some of the entertainment information, let's say video or whatever. So right now, how do I locate this resource block to the vehicle under CV2X in 5G? We call this as a resource allocation issue. So right now, the standard has defined 4 modes of resource allocation. So here, the UE stands for user equipment. Basically, it's a mobile device. That's a typical term under 3GPP. ENB actually stands for E-Node B, basically just a base station. So under mode 1, the UE or the vehicle, okay, will be allocated a resource assisted by the base station. And the base station will allocate certain number of the dedicated resource block for the vehicle to transmit the data. So that means under mode 1, the network may reserve certain number of the dedicated resource, radio resource to allocate to the vehicle for data transmission. In mode 2, the vehicle is able to randomly select the radio resources or resource block from a resource pool. But that resource pool has been used and before by the base station. That means maybe the base station has using 100 resource block to send the information for the vehicle, to let the vehicle to use. Then the vehicle has to choose from this 100 previously used resource block. Mode 3, so the vehicle resource allocation just assisted by the base station, but they are able to use the common resource, not the dedicated one. In mode 4, the vehicle will be able to choose the resource, randomly, not randomly, autonomously by themselves with certain sensing capability. For example, the vehicle may be able to sense the channel quality, in the media in order to select a radio resources on their own. So among these 4 modes, only mode 3 and mode 4 will be able to support what we call this ultra reliable low latency communication. That means able to support some application or some message which require a very low delay or very minimum delay. For example, safety message. For the safety message require very low delay because we have to send the safety message to the other vehicle as soon as possible. Otherwise, accident sometimes will happen. Okay. So these are the application that has been developed. For example, some hustle warning. So if you have the V2X, that means in advance, you may be informed a certain distance away there's some hustle. For example, black ice, or in certain distance from you, there's some road construction. So you will be able to know that. After that, you have to slow down, in order to avoid accident. An application is called the collision prevention. So, for example, if a car is behind a big truck, it happens that this car want to take over to the big truck. So, but if another car is coming in the opposite side, actually that would be very dangerous. So if we have this V2X capability, then the car behind the truck will be able to notice that, that some car is coming, so that this car will not take over. So again, this kind of taking over accident is very common, in New Zealand here as well, because our road is not so wide, particularly in some suburban, some of this rural area, is only 2 lanes. Another example is the intersection collision, so that the car, when they, will be able to detect the blind spot, so that will help save a lot, reduce a lot of accidents. Another application is platooning. Platooning basically is a serious number of cars. They drive one by one from each other with a fixed speed and fixed separation distance. The reason is that by this platooning, the car can save more energy because they can keep the same speed, and also the wind friction will be reduced, so that will be using less energy. Less petrol. So that platooning is a good application for the truck. So now in the Europe right now, some of them have already deployed this technology for their truck, because normally their truck will be driving a long distance, many of them from one country to another country. Is very common in Europe. Okay, so now we move on to the last part of my talk. So I'd like to show you some of the live demo. Some of the demo we make with my student, in this topic. We mainly want to show some of the one application for the video transmission. So what do we use to deploy the demo? So these are the hardware we need. So one of them is the V2X devices. One of them is called OPU, onboard unit. So the onboard unit will be installed in the car. These are based on L2.11p. So we can assume that is the OPU in the car, just a car Wi-Fi, where we have the antenna to be placed on top of the car, and we have another one, the roadside unit. So this roadside unit also is the V2X based on 11p to be installed in the building or in the infrastructure, like the traffic light. Again, you can consider this as a router you install in the ceiling. Other than that, we also need to use the mesh router based on 11AC, because we like to connect 2 different roadside units. Let's say we want to connect 2 different traffic lights, so that the traffic light data will be able to exchange using the wirelessly. So that's how we deploy, the vehicle design, how we put the thing. We can put the camera inside to detect the driver behavior. We also need to put some computer, OPU, and router as well. So because of the scale, actually it's a small scale for my deployment. So basically, this is one building near in our city campus. So what I do, I install only 2 roadside units of one building. So that is the setup. So you can see in that roadside, in one of them, we put the camera. That is the roadside unit. And this one actually is the mesh router antenna, because we need to communicate 2 of them on the same building. So that is the final setup. Okay, so that is the driving route. So basically, this triangle is our city campus. It's not really big area. So where we are, if you can see the map, St. Paul Street. So basically, that is where we are right now, our location. So basically, we are driving along this triangle route. Okay, first we have tried 2 cases in V2V. Basically, it's vehicle-to-vehicle communication. So in that V2V, 3 vehicles are driving along the AUT city campus. So we have car 1, car 2, car 3. Car 1 basically is a source which will install the camera. And then car 2 basically you can consider as a relay. And car 3 is a destination. So the source video from car 1 will be forwarded to the car 2 as a relay. And the car 2 will relay the video message to the car 3. So the idea is see whether car 3 is able to see the video captured from car 1. So basically, it's a simple demo. We're just driving along the campus and then to see the outcome. Okay, case 2, we have 2 vehicles, but one of them will be joining from the junction, something like this, right? Car 3 actually is somewhere. So car 1, car 2 start to drive. After that, car 3 will join, and then we want to check whether car 3 will be able to receive the video. Okay, so let me try to show you. Hopefully, you can see the video. So are you able to see the video?
Yes, sir.
Okay, good. Thank you. Yeah. Okay. Yeah. Even though it's a really small demo, but really cost a lot of people and then really time consuming. So for the large scale one, would definitely very difficult. So this is set up the car 1, car 2, car 3. So I just use up. I need to ask all my colleagues, my student, my researcher to be involved. Very time consuming. So this OBU. Okay, case 1. Okay, so the car 1 has a camera to capture video, and car 2 is to relay. So that is the car 1. So what the camera capture, and car 2 is a relay. Okay, so car 3. So sorry that the effect is not so good. Yeah, because we are not professional. But you can see in the beginning we are not able to see the video. I mean, look at the laptop, not clear because needs some time to set up the connection. But later, I hope that you can see, the laptop able to see the sky and the people walking. Basically, these are coming from the car 1. Okay, so now we leave our main street and then we drive along. Okay, so now you can see the connection is not that good when we drive because sometimes due to the speed and also some of these interruption in between the car, between car 2 and car 3. So the signal actually is not receiving well. So now we go back to the row, to the original starting point. Okay, so now here is more clearer, and also the speed is slower. So now if you go back to see right now, then the video looks more clearer. Okay, so case 2. So car 1, car 2 start to drive first, and then we want to check whether a car fleet will be able to join the network, I mean, from anytime. Okay, so we enter the row. So now you see the car fleet on the side now joining. So we see whether the car fleet will be able to join. Okay, for this one looks much better because car 1 and car 2 actually are moving very slow, I mean, in this row. So they were able to capture the car fleet is able to capture the video. Okay, I mean, for stationary, for sure, no problem. So when the car is stationary. Okay, so that is one of them. So we move on for the case 3. Okay, the last video I want to show is this one. Now I want to try V2I. So now for the V2I, we only have 2 vehicles because their communication right now is go through the infrastructure, go through the roadside unit installed at the building. So that is what we install right now. So this is the row. So if you can see the yellow RSU, actually we have deployed 2 roadside unit on this building. So we are starting from this side near the roadside unit. Okay, so let me see if I can. So the other one. Okay, similar setup. Actually, it's quite tedious, and lots of setting need to be done in advance, and that device, DSRC is not really user friendly. So actually, because this product, we got this one from a startup company. Okay, so car 1 same has a camera, and we try to send the video to the car 2. Okay, so now in the beginning, you can see the result is quite good because we are on the road now with the 2 roadside unit. So basically, the video signal from the other car is through that roadside unit from the infrastructure. So that means this is in the end of the road right now. Looks like that the infrastructure, the roadside unit, still provide good coverage to give the video to the other car. But as you can see, when we move out of that street, that means we are really far from those 2 roadside units, and the other car 2 really cannot receive anything. So for this testing, we do not we do not use the V2V, only V2I. That's why the connection purely based on the infrastructure, based on the roadside unit. So that means now the car 2 has not received any signal from the roadside unit. So basically completely rubbish. Okay, so now we go back. Yeah, so once we go back to the road, then can see the signal come back again. Okay, yes. Okay, so basically this is the second video I'd like to show you. So I think more or less I finished. So my last slide is that, are we ready for the smart city? I hope every one of us is ready, and we will see some of the smart city, happening in everywhere. Thank you very much. Yes, that's all.
Yeah. Thank you so much, sir. Thank you very much. And
Thank
we are
you.
really honored, and it's a pleasure for us that you take out time and joined here. Thank you so much. Dear participants, if you have any queries, you can put forward. Any queries?
No. So, Professor Chong, thank you very much. Join
No
again.
problem. Yeah.
And we are really honored, and definitely your session will be informative one, and the participant will get definitely benefited from that.
I hope so. Thank you so much. Yeah.
So once again, if any one of you have any question, kindly ask. No, then Pali, might be.
Yes. Thank you, sir.
Okay.
Now I think all of us we get idea about V2X and V2Geek and all the types of companies.
Excuse me, I have a query. Hello.
Yes,
Hi.
yes.
Yes. Sure. Yeah.
Peter, can you elaborate like where exactly artificial intelligence can be useful in this smart city projects? Like,
you mean,
is it immediately after the sensing of the data,
oh,
or is it at the application end
you mean
user?
for the V2X, right? AI for
Yes, yeah,
V2X, correct? Oh, there's
yes, yes, yes.
a lot of things you can do AI for V2X, particularly for the resource allocation, for the resource block allocation. So now many of the work, even my student right now is to use the AI to allocate the resource to the car, because the loss of complexity there in terms of traffic interference and also the co-channel interference. So yeah, I mean, actually, this V2X, right, is very similar to the traditional wireless network, cellular network. The only difference is that instead of the human, basically it's a car to do the communication. So that is very typical, kind of traditional. But the only difference is that we need to consider is the speed.
Okay. And my second query is on like what were the factors, means why your report, your New Zealand, when you are doing a study whether these smart city projects are feasible or not, there was a conclusion you mentioned that
Oh,
the feasibility is unclear. So
okay.
can you put through some light that why it was unclear? Means what are the difficulties from economic or cost point of view of
Okay.
these projects?
Okay. I talk about, okay. I talk about the two different standards for V2X,
Yes,
DSLC and 5G, right?
yes,
Okay. So okay, again, this is also very similar to our traditional communication, right? If you recall, there's always a Wi-Fi and cellular are competing, right? In the old day, I think Wi-Fi has less advantage because cellular gives you wider coverage. But at the end, right now, Wi-Fi is also very popular. It's complement to the cellular. So that is exactly same happen to the car communication. So we have, I can see we have a car Wi-Fi, DSLC, and 5G V2X. In the beginning, 5G V2X will be picked up first because of the infrastructure already existent. So car Wi-Fi DSLC will be later because you still need the investment to deploy this one. But I believe these two will not be competing each other because cellular still will not be able to cover everywhere. In some location, 5G operator may not be willing to deploy. So now there's a room for the independent Wi-Fi operator to install this DSLC. Yeah, but in the beginning, cellular V2X will be picking up first because of the infrastructure. Yeah.
okay. Thank you, Professor. Thank you.
Yeah.
Any other query? Okay, Professor, I think there are no more queries. And
Okay, good.
we are really thankful and
No
we are also
problem.
looking forward that in India also will be benefited with this technologies, and we will also be living in the smarter cities very
Oh,
soon.
okay, good.
So
So I'm here 10:30 p.m. right now. Good time for me to go to bed. Okay. Anyway, thank you so much. Thanks a lot for your for inviting me and your joining. Okay. I hope let's keep in touch.
thank you for joining, sir, and we are looking forward for a few more lectures ahead in the future.
Sure, sure. Thank you, Dr. Singh. Thank you.
Thank
Thank
you.
you very much,
Yeah,
Dr.
you
Peter.
too. Okay. Good night. Good night. Bye bye. Bye bye.
Okay.
Good night, sir.